I've got the half angle formulas for sine and cosine on the board. We derived those in the last video. Now we're going to use them to derive the half angle formula for tangent. And it turns out there are actually 3 versions of that, which is not immediately obvious. So let's just take a look. If I wanted to calculate tangent of alpha over 2, I know that tangent is just sine over cosine. So that would be sine of alpha over 2 over cosine of alpha over 2. So I can just take this formula and put it on top of that formula. So I will have plus or minus the square root of 1 minus cosine alpha over 2 all over plus or minus the square root of cosine alpha plus 1, or I could write that as 1 plus cosine alpha, it doesn't matter, all over 2. Now, a couple of things to note here. First of all, plus or minus over plus or minus, there are really only 2 possibilities. It's either going to be plus or minus. So I don't need to write 2 plus or minus signs. I can just say it's going to be plus or minus this fraction. And with square roots do distribute over division. So I can say this is one big square root of 1 minus cosine alpha over 2 divided by this fraction, which would mean multiplied by 2 over cosine alpha plus 1. I put it all under one root, and then it was just the top fraction divided by the bottom. Notice those 2's are going to cancel. So we end up with plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. And just like with sine and cosine, this plus or minus is not just a random choice. It's not saying that both are correct. This plus or minus is going to be determined by the quadrant of alpha over 2. Okay, now this one, if I know these 2, I can get it fairly quickly because I know tangent is sine over cosine, so I'm basically going to have this over this. I can see that the 2's are going to cancel, so it's the top of this fraction over the top of that fraction, all under the root with the plus or minus attached. Okay, so that's the version that falls out most directly from working with just these 2 formulas. I'm going to erase these now and show you the other 2 versions, which it turns out are a little bit more user-friendly. So we had plus or minus the square root of 1 minus cosine of alpha over 1 plus cosine of alpha. Okay, now if I take this, I can say tangent of alpha over 2 is plus or minus. Now I'm going to go back to writing this as a square root over a square root. Don't absolutely have to, but I think it makes life a little bit simpler if I do it for what I'm about to do. Now, I'm going to take this and I'm going to multiply it by 1. That's something I do an awful lot. I'm going to multiply it by 1 in the form of the square root of 1 minus cosine alpha over the square root of 1 minus cosine of alpha. So I'm just going to take the root that I have on top and multiply by 1 in the form of that root over itself. Okay, so we will have plus or minus. Now on top, I'm squaring a square root. When I square a square root, that just lifts the radical. I'm going to get 1 minus cosine of alpha. Okay. And when you start with a square root and square it, that's not when we need to worry about absolute values. This square root can only be defined if what's under it isn't negative. Okay? 1 minus cosine alpha can never be negative because cosine alpha can never be bigger than 1. Okay? So when I square it, I do get this non-negative quantity. Okay. Now on bottom, I can use the fact that square roots distribute over multiplication. So I can say, okay, this is the square root of this product, but notice these are the same 2 terms connected with opposite signs. It was a sum of 1 in cosine and a difference of 1 in cosine, so I'm getting a difference of 2 squares. First terms are going to give me 1, Outsides and insides cancel. Last terms give me minus cosine squared alpha. Pythagorean identity, that's the square root of sine squared of alpha. So I'm going to have plus or minus 1 minus cosine alpha over the square root of sine squared alpha, which is going to be plus or minus 1 minus cosine alpha over the absolute value of sine of alpha, which is going to be plus or minus 1 minus cosine of alpha over plus or minus sine of alpha. But just like when we had it last time, there's no need to write the plus or minus twice. There are really just two options. We're going to end up with something positive, or we're going to end up with something negative. If we end up with 0, then either sign would be correct. So I can just write one plus or minus sign and say it's plus or minus 1 minus cosine alpha over sine of alpha. Okay. But now, there's a really nifty fact. Okay. So first of all, notice that right now we've just gotten rid of any square roots. That's fabulous. Okay. So that's going to be a lot more user-friendly to work with just because we're going to have simpler things. We're not going to end up with roots of roots. We might have roots in cosine alpha or sine alpha, but they're not going to be under another square root. Okay. There's another really nifty fact, and that's that the plus or minus sign, SIGN, of tangent of alpha over 2 always matches the plus or minus sign of sine of alpha. So the SIGN of sine the trig function of alpha. Okay. Now what's really cool about that, we said the top here is never negative. The top is either going to be 0 if cosine of alpha happens to be 1, or it's going to be a positive number, because cosine of alpha is never bigger than 1. So the sign of this fraction will match the sign of the denominator, the plus or minus sign of sine of alpha. So whether this fraction is positive or negative will be determined by whether sine of alpha is positive or negative. But the plus or minus sign here, which is the plus or minus sign of this fraction, matches the plus or minus sign of tangent of alpha over 2, which means it's not necessary to write that plus or minus, because this is guaranteed to give you the right sign. So you don't need to look at what quadrant you're in. If you work with this, magic, actually, well, math is kind of magical, okay, the sign is going to be correct. Now, that's because of this fact, which I have just stated, okay? You're going to take a look at why that's the case in homework problem number 45. You're going to play around a little bit with some different possibilities of what quadrant alpha could be in and where that puts alpha over 2 and what that makes the SIGN, the plus or minus sign of sine alpha and of tangent of alpha over 2. And you'll see as you work through those problems that the plus or minus signs always match. So, two nifty things about this version of the formula. One, there are no roots other than any roots that might show up in evaluating cosine of alpha and sine of alpha. Two, there's no plus or minus sign. So this version of the formula, while it follows a little bit less directly from the half-angle formulas for sine and cosine, it's much more user-friendly. Okay. Now it turns out there's a third version of the formula that we could have. So we've got this version, plus or minus sign, and a root with trig functions underneath it. Not super user-friendly, much more user-friendly. Okay. Let's see if we can find the third version. Okay. So we started last time with tangent of alpha over 2 equaling plus or minus, and then I just wrote this as a root over a root. Root 1 minus cosine alpha over root 1 plus cosine alpha. Now last time we multiplied by 1 in the form of this root that we had on top of the fraction over itself. This time I'm going to multiply by 1 in the form of root 1 plus cosine alpha, the root I have on bottom over itself. So we're going to get plus or minus. Now on bottom I'm squaring a square root, so that just lifts the radical, and I get 1 plus cosine of alpha. On top, I'm multiplying that out. That's going to give me my difference of 2 squares. I'm getting root 1 minus cosine squared alpha on top. But I know that that's just sine squared. So we're getting plus or minus the square root of sine squared alpha over 1 plus cosine of alpha. And now again, we can use that really nifty fact. This is never going to be negative. Okay. This is, of course, the absolute value of sine of alpha, which is either plus or minus sine of alpha. So we get a second plus or minus if we simplify this. But net result, it's going to be just either positive or negative. Okay. But the plus or minus sign of sine alpha always matches the plus or minus sign of tangent of alpha over 2. So I can say this just is equal to sine of alpha. That's taking the square root and the plus or minus into account over 1 plus cosine of alpha. So this version is also super user-friendly because, again, there's no plus or minus sign and there's no root over the whole thing. Okay. So these two versions of the formula, I think, are much more user-friendly than this one. They do both rely on that really cool fact that the plus or minus sign of sine of alpha over 2 matches the plus or minus sign, the plus or minus sign of sine of alpha matches the plus or minus sign of tangent of alpha over 2. Again, that's homework problem number 45. Do make sure that you take a look at that because that's a really useful thing in getting these formulas. If we didn't have that, there would have to be a plus or minus sign in both of these formulas, and we'd have to look at what quadrant we were in. Okay, good stuff.